this problem, we're going to, again, verify a trigonometric identity. We want to show that tangent of theta minus cotangent of theta divided by tangent of theta plus cotangent of theta is equal to 1 minus 2 cosine squared theta. We can start with either side. We're again going to just start with the left-hand side. Here we'll have the tangent of theta minus cotangent theta divided by tangent theta plus cotangent theta. We're going to rewrite each of these tangents and cotangents in terms of sines and cosines. So we're going to have sine of theta over cosine theta, minus cosine theta over sine theta, all divided by sine theta over cosine theta, plus cosine theta over sine theta. And we've got two fractions in the numerator and two fractions in the denominator. We'd like to get a common denominator so that we can combine these fractions, and get a common denominator so we can combine these fractions. Our common denominator is going to be the product of the denominators, cosine and sine. If we go ahead and do that, we'll end up with sine squared theta minus cosine squared theta divided by sine theta cosine theta. That would be our numerator. Let's drop our equal sign down here. Do the same thing in this denominator, and we'll get sine squared theta plus cosine squared theta divided by sine theta cosine theta. We notice that in our two fractions here, we have the same denominators. So if we were to invert our fraction in this denominator, multiply it times our numerator, those would cancel. What we would get is sine squared theta minus cosine squared theta divided by sine squared theta plus cosine squared theta. So those denominators will cancel. Sine squared theta minus cosine squared theta is going to be negative cosine of 2 theta, so a double angle formula. And sine squared theta plus cosine squared theta is 1. This is equal to negative 2 cosine squared theta minus 1. And if we distribute our negative, we'll get 1 minus 2 cosine squared theta, which is our right-hand side.